Hey guys, we are going to add fractions today. So remember, whenever we add fractions, what's really important is that we find a common denominator. And we've talked about the steps that you take to find a common denominator. So the first one would be, is 3 a factor of 5? Can we change a 3 into a 5? And that answer is no. So the second thing we would want to do is multiply them together. So 3 times 5 is 15. So we can change them both into 15ths. And then remember, the way that we change them into 15ths is by making equivalent fractions. 5 times 3 is 15, and whatever you do to the bottom, you got to do to the top. So we just traded in 1/5 for 3/15. So really we're kind of done with that, and if we want, we could write that below. And then over here, we're going to do the same. 3 times 5 is 15, and whatever you do to the bottom, you've got to do to the top. Oops. So that's 10/15. Done with that. So now I'm going to add these two fractions. And I just add the numerators. 10 plus 3 is 13, and I keep my denominator of 15. 13/15 is in simplest form because 13 is prime, and 15 is not a multiple of 13. Okay, let's try another one. First thing we do is say, can we change a 3 into an 8? No. So, second thing we do is 8 times 3 is 24. And we can do that. But what I notice here is that 6/8 can be simplified. And so I might be able to find a better, lower fraction, an easier fraction to work with if I first simplify 6/8. So I'm going to simplify 6/8, and I'm going to say they can both be divided by 2. So 6 divided by 2 is 3, 8 divided by 2 is 4. So now we're working with a smaller fraction to begin with. Now I start over. Can I change a 4 into a 3? No. So I'm going to do 4 times 3 is 12, and change them both to 12ths. 3 times 4 is 12, and whatever you do to the bottom, you've got to do to the top. 2 times 4 is 8. So 2/3 is the same as 8/12. 4 times 3, so 3 times 3 is 9. 3/4 is the same as 9/12, and now I add these. Once I get my common denominator, I just scoot it on over because we're talking about adding 12ths. 9 plus 7 is, or 9 plus 8 is 17. Now 17/12 is improper, so I have to say, how many times will 12 fit into 17? Once. How many leftovers do I have? 5. 5 whats? 5/12. 5/12 is simplest form because 5 is prime and 12 is not a multiple of 5. Now we're going to subtract. Same exact thing you do when you're subtracting, except in the end, you just subtract the numerators. So, can we change a 3 into a 4? No. So let's do 3 times 4 and make our denominator 12. 4 times 3 is 12, so 1 times 3 is 3. We're making equivalent fractions. 3 times 4 is 12, so 2 times 4 is 8. So I just traded in 2/3 for 8/12, 1/4 for 3/12. So now I've got 12ths, and now I can just subtract them. 8 minus 3. 8 minus 3 is 5, and my denominator of 12 stays. 5/12 is simplest form because 5 is prime and 12 is not a multiple of 5. Let's do one more subtraction problem. So I'm saying, can I change a 5 into an 8? No. So now I'm going to multiply them together. 8 times 5 is 40. 40 is a really big number. So what I might ask myself is, okay, can I simplify this first? No. Can I simplify this first? No. Sometimes I also like to ask myself, if 8 times 5 is 40, sometimes half of that could be a possible denominator. And so half of 40 is 20, so I say, can I change a 5 into a 20? Yes. Can I change an 8 into a 20? No. Right now, if you're watching this video, I would like for you to put a heart in the bottom left-hand corner of your page. So I'm going to change them both to 40ths. 5 times 8, so 3 times 8 to make an equivalent fraction. 3 times 8 is 24. 8 times 5, so 7 times 5 is 35. So now I'm going to do 35 40ths minus 24 40ths. It's going to give me so many 40ths. Now, 35 minus 24, you could just, think it through. If you ever have to do a little problem out to the side, like 35 minus 24, that's okay. Make sure that you do that if you need to so you get it correct. 11 40ths is our answer. This is in simplest form because 11 is prime and 40 is not a multiple of 11. So there we go, adding and subtracting fractions. See you next time.